We're being asked to find the slope and y-intercept of each equation, and we're given the hint that sometimes we need to solve for y first. In the first couple of equations, we see that y is already alone, so there's no need to solve for y. We just need to think about this in terms of y equals mx plus b, and sometimes it helps to write that formula right underneath our work. Now the b is pretty easy to identify. The y-intercept is the point 0, 3/2. The slope is a little bit harder to identify because at first glance, we don't even see a number in front of the x. So we have to remember that when there's no coefficient written, that coefficient is really a 1. So my slope is 1. In the second problem, we have y equals negative 2/5 x. Again, we can write y equals mx plus b. And this time we notice there's nothing in this space. So we have to think about what's the only number that if we add it, nothing happens. Well, if I add 0, nothing happens. So that tells me that my y-intercept is the point 0, 0. My slope is easy to see, negative 2/5. Now here's one that often throws us off. It really helps if we take a look at it, because notice, I can write y equals mx plus b, but that doesn't align at all. And I can't solve for y because there's no y in the problem. So I need to remember what a line of x equals 4 looks like. Remember, I would go to 4, and I would make a vertical line so that every point on this line starts with 4. So it would be 4 comma anything at all. Now we know that a vertical line doesn't have a slope. So we can say no slope, or we can say undefined. You can't say 0 because that's a different kind of line. This line also doesn't have a y-intercept. It's parallel to the y-axis. So this is almost a trick question. Since we're here, let's just do the problem right underneath that. We have y plus 2 equals 1/2 x minus 4. Now remember, there was the hint, solve for y. So let's start by subtracting 2 from each side. Now that we have subtracted 2, it looks a lot more like y equals mx plus b. We can see that our slope is the 1/2, and our y-intercept is the point 0, negative 6. Working our way back through this row, again we need to solve for y. Let's subtract x from each side. So negative 3y equals negative x plus 12. Notice I put the x term first because I want it to look like y equals mx plus b. And I had to include a plus sign in front of that 12 because the 12 was positive. Now I'm going to divide both sides by negative 3, and y is equal to, don't let this throw you off, that negative x is really a negative 1x. So this is negative 1 over negative 3, or 1/3 x, and 12 divided by negative 3, which is minus 4. So my slope is 1/3, and my y-intercept is the point 0, negative 4. Again, we need to solve for y. Let's start by subtracting 2x. Y is equal to negative 2x plus 5. That was just a one step to get y alone. I can see that my slope is negative 2, and my y-intercept is the point 0, 5. Now this is another special line. I can picture this one to figure out how to make it work, or I can try to rewrite it. If I think of y equals mx plus b, notice there's no x term. So this would be like y equals 0x plus 5. In that case, I can see that my slope is 0 and my y-intercept is the point 0, 5. But maybe I'm puzzled and I'm not exactly sure how to work that out. So instead I could picture it. If I picture this line, if I go up 5, I would have all the points on this horizontal line, all the points that are something, comma 5. From there I can go, oh yeah, I know that all horizontal lines have a slope of 0. And I can see the y-intercept from the quick graph. Moving back across, I can see that I have to subtract 5x from each side, leaving negative y equals negative 5x plus 6. If I either divide both sides by negative 1 or multiply both sides by negative 1, that will take care of the negative in front of the y. So y is equal to 5x minus 6, giving us a slope of 5 and a y-intercept of 0, negative 6. This one also needs to be solved for y, because this one's written in a form called point-slope form, and not in the slope-intercept form. First, we've got to distribute that 2. So y minus 3 equals 2x minus 2. Then we need to add the 3 to each side, and y equals 2x plus 1. So our slope is 2, and our y-intercept is the point 0, 1. In the next section, we're asked to write an equation of the line with the given slope and y-intercept. So we're simply being asked to plug the values into y equals mx plus b. If my slope is 2, then I have y equals 2x. I can write plus 0, but I should always simplify when I can. So I would say y equals 2x, and that would be the entire equation. Next, I have a slope of 1, so I can think of that as y equals 1x and a y-intercept of 4, but again, I should simplify when I can, and this is simply y equals x plus 4. Next, we're asked to write the equation for each of these lines. So it helps if we start by identifying the y-intercept, in this case the point 0, 1, and then we need to determine the slope. So we find another point somewhere on the line that we can clearly identify, and then we look at our change in y, which in this case we're going up from 1 to 6, so that's a change in y of 5, and then my change in x, which is just going 1 to the right. So my slope is 5 over 1, or just 5. My y-intercept was the point 0, 1, so I can write y equals 5x plus 1. This next line is horizontal. I can see that it goes through the point 0, negative 3. We know that all horizontal lines have a slope of 0, and if I have 0x, that x term will be gone. So the equation for this line is simply y equals negative 3. My third line is vertical. This goes through the point negative 2, 0. We know that vertical lines don't have a slope. So their slope isn't 0, it simply doesn't exist. So I cannot write this in y equals mx plus b form. But I do know that all the x values on this line are negative 2. So the equation is simply defined as x equals negative 2. When we graph in this method, we're first going to plot the y-intercept. So if I'm looking at this first equation, I know that I need to start by plotting the point 0, negative 2. Then I need to follow the slope of 2/3. So remember, 2/3 is my change in y over change in x. So from the negative 2, I need to count 2 spots up and 3 spots to the right, and then repeat 2 spots up, 3 spots to the right. I can reverse that to continue the line. 2 spots down, 3 spaces left, 2 spots down, 3 spaces to the left. And I can draw my line. I always want my line to go all the way across the graph. I want it to have arrows on the ends, and I want 2 points labeled. Typically, we label the y-intercept and then any other point along the line we might choose. So for this next one, I can see that my slope is negative 1, and my y-intercept is the point 0, negative 3. So I can graph 0, negative 3. When I think of a slope of negative 1, first of all, I want to remember that anything divided by 1 does not change in value. So when I have a whole number, I can give myself a rise and a run. This is my change in y over change in x. So this tells me to go down 1 and right 1, and I can reverse both of these going up 1 and left 1, so that I get points going all the way across my graph. When I draw my line, I want to make sure to label 0, negative 3, and some other point along the line. This time I'm choosing to go a little further away so that I have enough space to write both coordinates. Finally, remember that y equals 4 means I would go up to 4, and then any other point with a 4 in its y is also along my line. So this is a horizontal line through the point 0, 4, and then I need to label something else. In this case, I'm choosing to label 3, 4.